Ever wondered how a tiny USB drive can hold thousands of photos, videos, and files? Or how your smartphone stores all your apps, pictures, and memories in such a small space? It's all thanks to a fascinating technology called flash memory. Stick around, and we'll uncover how this amazing tech powers the storage devices we use every day. We're going deep into what flash memory is, how it works, and why it's so crucial to modern technology. By the end of this video, you'll know everything you need to know about the magic that keeps our data safe and accessible. What is flash memory? To kick things off, let's break down what flash memory really is. Flash memory is a type of non-volatile storage, which means it keeps your data saved even when the device is turned off. This is fundamentally different from the RAM in your computer, which loses everything once the power is cut. But here's what makes flash memory special. Unlike traditional hard disk drives, HDDs, which rely on spinning disks and magnetic fields, flash memory uses electrical charges. This makes it not only faster but also more resilient and versatile. So, whether it's a USB stick, an SD card, or the internal storage of your smartphone, they all use flash memory to hold your precious data. Now, you might wonder, what exactly does flash mean? The term flash comes from the way data is written and erased in these devices. Imagine wiping an entire chalkboard in one quick sweep. That's essentially how flash memory handles data. It can erase data in large chunks or blocks at a time, making the process fast and efficient. This efficiency has made it a preferred choice for everything from consumer gadgets to professional equipment. How does flash memory work? Now, let's dive deeper into how flash memory works. At its core, flash memory consists of millions, sometimes billions, of tiny cells, each holding an electrical charge. These cells are arranged into grids called pages, and a collection of pages forms a block. Each of these cells has two key components, a floating gate transistor and a control gate. The floating gate is insulated by an oxide layer, which traps electrons. When a voltage is applied to the control gate, electrons can either be added to or removed from the floating gate, which changes the cell state between a 1 or a 0. This is the fundamental process of storing digital information. But here's the clever part: flash memory doesn't write data one cell at a time. Instead, it writes to pages and erases data in blocks. Think of it like a notepad where you can write on any line you want, but if you make a mistake, you have to erase an entire page. This block-based structure makes flash memory incredibly fast for reading data, but slightly slower when it comes to writing or deleting data. Types of flash memory: NAND versus NOR. There are two primary types of flash memory, NAND and NOR. These names come from the logic gates they are based on. Let's explore both types in more detail. NAND flash. NAND is the most common form of flash memory today. It is designed to provide high storage capacity and fast read/write speeds at a lower cost. NAND flash can be further divided into different types, such as single-level cell, SLC, multi-level cell, MLC, triple-level cell, TLC, and even quad-level cell, QLC, flash. SLC NAND stores 1 bit per cell, which makes it the most reliable and durable but also the most expensive. It's often used in industrial applications and high-end SSDs. MLC NAND stores 2 bits per cell, offering a good balance between cost, speed, and durability. TLC and QLC NAND store 3 and 4 bits per cell respectively, providing higher storage density, but at the expense of speed and endurance. NOR flash, on the other hand, has faster read speeds and is used in applications where data integrity is critical, such as firmware storage in phones, routers, and embedded systems. Unlike NAND, NOR allows for random access to any memory location, making it ideal for executing code directly from the flash memory. However, it is slower and more expensive to produce than NAND, which is why it is less common in consumer devices. Why NAND flash dominates the market? So why is NAND flash so widely used? The answer lies in its scalability and cost-effectiveness. As the demand for more storage increases, whether for larger files, higher-resolution videos, or more apps, NAND's ability to stack more cells in the same physical space makes it ideal. Techniques like 3D NAND, where memory cells are stacked vertically, further increase storage capacity without increasing the physical footprint. How USB drives use flash memory now? Let's see how this technology is used in USB drives. Inside a USB drive, you'll find a NAND flash memory chip and a microcontroller. The microcontroller acts as the brain of the device, managing data transfers between your computer and the flash memory. When you plug a USB drive into your computer, the microcontroller interprets your computer's commands, whether you're saving files, deleting them, or even formatting the drive. It decides where to store the data and how to manage the electrical charges in the cells. This process is incredibly efficient, allowing USB drives to operate at speeds much faster than traditional hard drives. But USB drives are more than just convenient, they are also incredibly durable. Because they have no moving parts, they are resistant to shocks, drops, and even temperature extremes. Plus, they consume very little power, which makes them perfect for portable use. The role of flash memory. In SD cards, flash memory also plays a critical role in SD cards. An SD card is essentially a miniaturized version of a USB drive, designed to fit into smaller devices like cameras, drones, and smartphones. An SD card contains a NAND flash memory chip, just like a USB drive, but it also includes additional components like a wear leveling controller and a host controller interface. The wear leveling controller helps extend the lifespan of the card by evenly distributing data writes across all the memory cells, reducing wear and tear. There are different types of SD cards: SD, SDHC, SDXC, and SCHC, each offering varying capacities and speeds. For example, SDXC cards can hold up to 2 terabytes of data and have faster read/write speeds, making them ideal for capturing high-definition video or burst photography. SD cards are engineered for reliability, speed, and efficiency, which is why they're the go-to choice for many professional photographers, videographers, and tech enthusiasts. Why flash memory is fast and durable? What makes flash memory so fast and durable? Let's dig deeper. Firstly, the speed. Flash memory is much faster than traditional hard drives because it has no mechanical parts. There are no moving platters or read/write heads that need to find data. Instead, data can be accessed almost instantly because it's stored in the cells, which are accessible directly via electrical signals. Secondly, durability. The lack of moving parts also makes flash memory more resistant to physical damage. You could drop a USB drive from a reasonable height or expose it to a little moisture, and it would likely still work. That's not something you can say about a traditional hard drive. Moreover, flash memory consumes less power, which is essential for portable devices like smartphones, tablets, and laptops, helping them run longer on a single charge. The limitations of flash memory. However, flash memory isn't perfect. One significant drawback is its limited write endurance. Every time data is written, erased, or rewritten, the memory cells degrade slightly. This is because the oxide layer that traps the electrical charges wears down over time, eventually causing cells to fail. To mitigate this, manufacturers employ various techniques such as wear leveling and error correction code, ECC, to distribute wear evenly across cells and correct any data errors that occur. But, despite these advancements, the lifespan of flash memory is still finite, though it's more than enough for most consumer applications. How flash memory has evolved over time. Flash memory has undergone incredible evolution since it was first invented in the 1980s. The initial versions were expensive, had limited storage capacities, and were used primarily in niche applications like military or aerospace equipment. However, as manufacturing processes improved, costs came down, and storage capacities increased. With the advent of the digital age, flash memory found its way into consumer electronics. In the early 2000s, USB drives started replacing floppy disks and CDs, while SD cards became the standard for digital cameras. Today, flash memory is even used in data centers, supporting high-speed servers and cloud computing infrastructure. The future of flash memory. Looking ahead, the future of flash memory is exciting. Emerging technologies like 3D NAND are pushing the boundaries even further by stacking memory cells vertically, which increases storage density without requiring more physical space. This technology is already being implemented in high-end SSDs, and it's only a matter of time before it becomes mainstream. Other innovations, such as QLC, quad-level cell, NAND, promise to further increase storage capacities and reduce costs, although they still face challenges related to speed and endurance. Conclusion: flash memory might be tiny, but it's mighty. It's the unsung hero behind some of the most important tech we use every day. So, next time you plug in your USB drive or pop an SD card into your camera, remember that a world of innovation and engineering lies inside. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more deep dives into the tech that shapes our lives.